Hello everyone. In last section we have discussed about movement about origin. Now in today's section we are going to discuss about movement about mean. Okay, in the movement about mean we are going to discuss about variance concept in this session. Myself Dr. G. Karthik Reddy, working as Associate Professor in the Department of ECE, MLR Institute of Technology, Hyderabad. Okay, we are going to discuss about movement about mean. What is movement about mean? Movement about mean. Okay, movement about mean and movement about origin. What is the major difference? Movement about origin means, okay, you are having the some random variable x. Okay, we are, for example, if you are taking the, I'll take the one example, then you will get clarity. Movement about origin. Okay, we will take the Gaussian. Okay, x is a random variable, fx of x. Okay, here if you are considering the variation of the random variable with respect to expectation. Okay, here you know the formula, fx of x is equal to 1 by square root of 2 pi sigma x square expectation of x minus mx whole square by 2 sigma x square. This is a formula for Gaussian. Now here when you consider x equal to mx, then what happens? 1 by square root of 2 pi sigma x square e power minus x square by 2 sigma x square. Okay, here what is the problem means, here there is no variation. Variation with respect to mean, there is no variation. We are taking the only with respect to x. Then here the mean value is 0. Mean value is 0. Means the random variable with respect to variation is 0. Then we are going for, in this terminology, movement about mean, we are having the x is a random variable, x bar is the expectation. Expectation of random variable x only. Random variable x only. The x we are differentiating. Okay, you can take x plus or x minus. Okay, in generally we are taking as per standard notation x minus x bar. Okay, how much is the variation we are taking? Because always the expectation we are taking for positive values. That is why we are taking only the right side part only. Okay, we are taking only the right side part. We are not considering the left side part. Whatever the shifting we are taking. Okay, we are taking x minus. Okay, we are taking this is x 0. X minus x bar means you will get here. X plus x bar means you will get this side. Okay, with respect to origin, you have to take some reference. Here we are taking the reference as origin. From the origin, whatever the variation you are going to get, this is the x minus x bar. This is x plus x bar. Okay, we will take the expectation as positive value. That is why we are considering only x minus x bar. Now here the formula also comes into the picture in the same manner. Okay, movements about mean means movements we are considering with respect to mean. Okay, with respect to mean, that is why you are taking x bar also. Okay, in previous movement about origin you are having, what you are having movement about origin? In movement about origin we are having only x power n. Here we are having x minus x bar power n. Okay, x minus x bar power n. Okay, x minus x bar power n, where n equal to 0, 1, 2. Now this is a formula. Expectation of x minus x bar whole power n. Integration minus infinity to infinity. Small x is a value assigned to the random variable capital X, and x bar is the expectation of the random variable x, and small fx of x represents probability density function. Probability density function. Okay, here the probability density function. Okay, here movements about the random variable. Here also you will get the, it is denoted by mu n. Okay, movement about origin is denoted by mn, and movement about mean is denoted by mu n. Okay, here we will discuss the movement about mean. Okay, movement about mean, for example, n equal to 0. N equal to 0 means expectation of x minus x bar whole power n. Okay, integration minus infinity to infinity x minus x bar whole power n fx of x dx. Okay, expectation for this one. Okay, this one what you are going to get, this power will become 1, and integration minus infinity to infinity small fx of x dx represents the area under the curve of any density function is always equal to 1. And this is a first statement. Now next, this is a next n equal to 1. N equal to 1 represents expectation of x minus x bar whole power 1, which is integration minus infinity to infinity x minus x bar power 1 fx of x dx. You further simplify this, then what you are going to get? Integration minus infinity to infinity. Okay, what you are going to get? You split this one x into fx of x dx minus x bar. Then what is this is called what? Expectation only. Expectation of x. Okay, expectation of x or x bar, both meaning the same. This represents what? Mean or expectation of random variable. Expectation of random variable x only. Okay, now here both are okay, to cancel out you will get 0. Means first order movement about mean. Movement about mean is first order movement about mean is what? 0. 0th order movement about mean is 1. Now next we'll discuss the second order. Okay, second order means n equal to 2. N equal to 2 means expectation of x minus x bar power 2. X minus x bar power 2. Then what you are going to get? Integration minus infinity infinity x minus x bar whole power 2 fx of x dx. Okay, this is for continuous. Discrete, what you are going to get? Summation I equal to 1 to n xi minus x bar. X bar is a constant. Expectation is a constant. Calculation, what you are going to get? Constant value only you are going to get. Okay, into fx. Okay, into here what you are going to get? P of xi. Okay, now next. This is for the case of continuous random variable. This is for the case of discrete random variable. Now next, we are going to get, you expand this one. You expand this one, what you are going to get? Integration minus infinity infinity. What you are going to get? Check it. Okay, a minus b whole square you can take. X square plus x bar whole square minus 2 into x bar. Okay, now remaining fx of x dx. You simplify it further. Integration minus infinity infinity x square fx of x dx. Okay, now here what you are going to get? Integration minus infinity infinity x bar square fx of x dx minus, okay, minus 2 you can take on outside. Integration minus infinity infinity x into x bar fx of x dx. Now next what you are going to get? This is called what? We already discussed. This is called mean square value. And next here this one is a constant. Constant you take outside. Then what you are going to get? X bar square, because this is constant. Integration minus infinity infinity fx of x dx. Now next what you are going to get here? Minus 2. This x bar is constant. Mean. Okay. Integration minus infinity infinity x into fx of x dx. Now you can conclude that this is called what? Expectation only. X bar. Means now remaining term is what? This minus infinity infinity fx of x dx is always 1. Okay, the area under the curve is always 1. Then what is the remaining? What you are having? What you are having? Expectation of x square plus x bar square. Okay, minus 2 x bar square. Then what you are going to get? Expectation of x square minus expectation of x whole square. What this meaning that? What is this meaning called? Okay, this meaning is called what? Variance definition. Okay, this meaning is called variance. Okay, now what we can conclude that n equal to 2. N equal to 2 represents movement about mean of second order. Second order movement about mean is also called as variance. Second order movement about mean is also called variance of random variable x. It is denoted by different notations. Variance of x or sigma x square, or we can denote by mu2. All the notations are variance only. Okay, mu2. Mu2 represents second order. And this is the formula is, what is that formula? Just now written. Mean square minus mean of square. Mean square minus mean of square. Okay, you can write down this also notation. Mu2 is equal to this one. Mean square value is called movement about origin. It is denoted as M2. Okay, expectation of x is a movement about origin of first order. That is M1 square. Okay, this is also one of the important formula. Mu2 represents second order movement about mean. This is second order movement about origin. This is first order movement about origin. Mu2 equal to M2 minus M1 square. Mu2 equal to M2 minus M1 square. Okay, you are having the variance properties also. some of the properties we'll discuss. Okay, variance of kx. Okay, variance of kx, where k is a constant. Okay, where k is a constant, here again the same formula you can use. Okay, you know the variance of x formula. Variance of x is equal to expectation of x square minus expectation of x whole square. Okay, expectation of x whole square. Okay, now here what you are going to get, this one expectation. Okay, you can use this formula, or you are having one more formula, variance formula, x minus x bar whole square. Okay, you can use either any one formula. Then what you are going to get, expectation of, in place of x, k into x whole square minus expectation. Okay, what you are having next, you are having expectation of kx whole square. This is called what? Okay, you are having the expectation of k square into x square minus what you are going to get, expectation of constant into x is a into expectation of x, k into expectation of x whole square. Now what you are going to get, this one as k square into expectation of x square minus k square into expectation of x whole square. You take k square common, k square into remaining term is called, what is that, variance only, expectation of x square minus expectation of x whole square. Then k square into variance of x. This is the formula. Variance of kx is equal to k square into variance of x. We will discuss one more property of variance. Now next, variance of variance. Okay, you are going to discuss variance of some constant. Okay, like what we can say, that kx plus b. Okay, kx plus b. K and b are constants. Then you have to use same formula, expectation of kx plus b whole square, mean square, minus mean of kx plus b whole square. You have to solve this one. What you are going to get? This one is a plus b whole square. A plus b whole square, you know it, a square plus b square plus 2ab. Here you are going to get. Now here what you are going to get? Expectation. What you are going to get, this one. Okay, expectation of kx plus b means you are going to get k into expectation of x plus b. You simplify it further, k square into expectation of x square plus b square is constant. Okay, here 2 into k is constant, 2 kb constant, expectation of x. Here you simplify remaining. Here what you are going to get? A square, a plus b whole square. Then again what you are going to get? K square into expectation of x whole square plus b square plus 2 into b into k expectation of x. Then what you are going to get? Simplify it further. Okay, this part is already simplified. This part we have to simplify. K square into expectation of x whole square minus b square minus 2 b k expectation of x. You check the similarities. Any similarities are there? This part will get cancelled. Minus b square, this one will get cancelled. Any cancellation you are having? No other cancellation, I think. Okay, k square into expectation of x square minus k square into expectation of x whole square. Okay, you are having k square into variance of x. This is the formula for the variance of x plus y. Now we'll do one more property, variance of x plus y. Variance of x plus y is, formula is variance of x plus variance of y. We have to prove this one. How to prove this? Take the LHS part. Variance of x plus y is equal to what? Again use the same formula. What is the formula you are having? Expectation of mean square, x plus y whole square minus what you are going to get? Expectation of xy mean of square. You simplify it further, what you are going to get? Expectation of a plus b whole square, x square plus y square plus 2xy. Here what you are going to get? Expectation of xy, expectation of x plus expectation of y whole square. Now you simplify it further, and what you are going to get? Expectation of x square plus expectation of y square plus 2 into expectation of xy minus then what you are going to get here? A plus b whole square. Okay, expectation of x whole square minus expectation of y whole square minus 2 into what you are going to get? 2 into expectation of x into expectation of y. Okay, we are going to get this one. Okay, expectation of x square minus x mean of square is, this is variance of x. Next, mean square means expectation of y square minus expectation of y whole square is variance of y. Okay, variance of y, and plus 2 into, actually this is a formula of covariance of x comma y. This is actual formula of 2 into covariance of x comma y. Means when x and y are correlated, this is a formula. If x and y are uncorrelated, means uncorrelated. If x and y are uncorrelated, sorry, I will write here, x and y are uncorrelated means, if x and y are uncorrelated, means independent to each other, then okay, then they are independent to each other, independent random variables, then you are going to get the formula variance of x plus y is equal to variance of x plus variance of y. Okay, similarly the formula will not be changed if the conditions are independent to each other. Then variance of x minus y is equal to variance of x minus variance of y, sorry, plus only. Okay, plus only you are going to get. Only for covariance you are going to get. When you include the covariance, then what you are going to get? When x and y are dependent to each other, then you are going to get minus 2 covariance. Okay, you are having x and y are independent to each other, the formula will be same. Okay, these are the formulas related to the variance and expectation and the movements. Okay, we'll conclude it by telling that for movement about mean, n equal to 0 represents 0th order movement about mean. Then what you are going to get? 0th order movement about mean, that is expectation of x minus x bar power 1, okay, power 0 is always equal to 1. Next, n equal to 1, then what you are going to get? Then the movement about mean is 0. And when n equal to 2 is called variance. Okay, generally the movement about mean, these are all called the characteristics of the random variable. To study or to understand the behavior of any random variable, we require these terminologies. Movement about origin and movement about mean is most times should require to understand the behavior of any signal or any function. Now next, n equal to 3. n equal to 3 represents skewness. Third order. This is called skew. Okay, skewness means normalization. Okay, this is skew. Skewness means we are having the normalization for this sigma x power 3, then it is called as skewness. Skew means only expectation of x minus x bar whole power 3. This is called skew. And this is called skewness. Why we are using skew and skewness means, here we are using skewness whenever you require. Okay, for example, if the curve is like this, okay, okay, how much it is having the more part, okay, it is skew to right. Okay, this is skew to right. Okay, skew to right. And next, this one is skew to left. Okay, most of the portion is lying on the left side, skew to left. Okay, skew to left and skew to left. To identify the skewness means how much the portion, maximum portion is either on the right side or positive axis or negative axis, we can identify by using the concept called skew. And one more concept is also there, that is n equal to 4. n equal to 4 represents expectation of x minus x bar whole power 4. This is called skirtiness. Okay, this one indicates the what is the peak level. For example, if you are having the curve like this, okay, these are the two different curves. Okay, this one is having more steeper, and this is having somewhat flat surface. Okay, it means this is having the maximum value of the skewness. Okay, maximum value of the skewness. All these are the statistical parameters which we are using for a particular random variable. Okay, to understand the behavior of any function of any particular random variable, we require basic terminologies: mean, or in our terminology we are calling that as expectation. Next, mean square value we required. Next, we required variance. These three are most important. In sometimes we are also using skew and skewness. These three are most important to understand the behavior of any particular random variable. Thank you.